This is Geometry Unit 11, Lesson 7 on cones and pyramids. Alright, let's start with a cone. A cone starts with a closed plane figure B called a base. So this is going to be our base. And point P is up here, is not on the plane of the base. This is called the apex of the cone. And if we draw line segments from each point on B to P, we create a cone. It doesn't matter what point you pick, you just all go to P from here and you create a cone. Okay, you can draw as many lines as you need as you go around, and you can see any point that I pick on here becomes a cone. It all comes to a point. Alright, so this is a cone. Now there are actually infinitely many of these segments. Only a few representative ones are shown here. So there's lots of ones in between here. If you put them all together, that creates a cone. Most of the time we use what's called a circular cone. It's a cone whose base is a circle. That's why it's called a circular cone. In a right circular cone, the altitude intersects the base at the center. The apex is directly above the center line of the base. So basically, if your right circular cone, this is your apex. Your altitude is right there, and it's perpendicular to the base, like so. On an oblique, the altitude is actually out here. So the height would be here down to the base. All right, and that would be perpendicular. So either way, that would be the altitude. Most of the time in geometry, most of our cones will be either right circular cones or regular pyramids. So if this right here is our right circular cone, we'll talk about the pyramid below. So a pyramid is a cone whose base is a polygon. So you have a base here, whatever it happens to be, and it comes to a point at the other end. So the base is a polygon, makes it a pyramid. If it's a circle, it makes it a cone. So a regular pyramid is a pyramid whose base is a regular polygon, which means all the sides are congruent and all the angles are congruent as well. And they have lateral faces that are all congruent isosceles triangles. Each face of this, well, this one's not oblique, but this one is. All the bases are congruent. All the angles are congruent for the base. And each of the sides is an isosceles triangle. So this is face isosceles triangle, this one's an isosceles triangle, the one in the back and the one in the side are isosceles triangles. And the apex is above the center of the base, so its distance is perpendicular around. So you can see that here on the hexagonal pyramid. It has all the sides equal on the base. This is a regular hexagon. All of the faces, 1, 2, 3, 4, 5, 6, are congruent isosceles triangle, and the apex goes to the center like this, being perpendicular. So that's the definition of a cone and a pyramid. Volume. For any cone, the volume is given by the formula V equals 1/3 BH. Now this is on your reference sheet as this, so you have to know what those letters stand for. Just like we did with the prisms, B is the area of the base. You have to know the area formulas for whatever kind of base it is, and H is the height that is measured perpendicular to the base. So if it's a right cone, then it would be straight up and down. If it's not, it's from the vertex to the base, and it would be perpendicular. And notice the volume of the cone is 1/3 the volume of a cylinder with the same height, base and height. So basically, a cone comes to a point and it loses 1/3 of the volume of a cylinder. Okay, so let's find the volume. The atrium of the National Museum of the Marine Corps is an oblique circular cone with a base diameter of 180 feet and a height, not counting the mast, of 135 feet. So this is a picture of it right here. I don't know how well it's going to come out on your picture when I copy it, but we'll see. So basically what's happening, this is an oblique circular cone. So we have a cone like this is the base, circle, and it's oblique. This is the base down here, and then it's going to go up kind of like this. And it's not going to be straight up and down. So your height is actually out here. And that's going to be 135 feet. And the diameter of this is 180. So that is your cone. So what is its volume? The formula is V equals 1/3 area of the base times the height. All right, now what kind of base is this? This is a circle. So this is actually going to be 1/3 times pi r squared times the height. Okay, so plug in your values. 1/3 pi r, in this case, since the diameter is 180, that means the radius is going to be 90. So pi times 90 squared, and then times the height, which is 135. Okay, so you can put this in your calculator. V equals 1/3 pi times 90 squared, and then times 135. And that is approximately 1,145,110.522 cubic feet. Okay, so there we go. It's just a formula. You just have to know what the area of the base is for the circle. All right, we have the pyramid of Menkaure. It has a square base of length 106 meters. So the base down here is a square, and it has a height of 61 meters. Okay, so if we draw a quick sketch of this, your base is going to be a square. Each side is 106, and it comes up it comes up to make a nice, I'll see if I can do my lines a little straighter here. Comes up to make a nice straight line here. All those are the apex is above the base, so the height comes down like this is 61. Excuse my drawing there. Okay, so the formula, V equals 1/3 area of the base times the height. What kind of base do we have? We have a square. So square is length times width, or base times, or side squared, because it's the same. And then the height is out here. So it's 1/3. It's going to be 106 times 106. And then the height is 61. So put that in your calculator. 1/3 times 106 times 106. Oops, too many. (106) times 106, and then times 135, or 61, I'm sorry, that was the last problem. And you get 22,845.333. Okay, so 22,845.33, and this is in meters, so it's cubic meters. So that's volume. Volume is 1/3 the area of the base times the height. Okay, we can also do surface area of cones. Surface area is basically the covering the outside and the bottom if you want to. The total surface area of a cone consists of two parts. You have the base area, which would be the area of the base here. All right, so the base down here is a circle, this one is a hexagon. And then the lateral area is the area the lateral faces or surfaces. So on this hexagonal pyramid, each of the faces is an isosceles triangle, and there's 6 of them because it goes around 6 because there's one for each base. You can see if I colored in right here, that's one face like that. There's 6 of them going around. Okay, now the lateral surface on a cone is a little bit different. It is curved like this. So if you kind of unwrapped it, it would be come to a point, and it would kind of look like this. And it would, whoops, it wouldn't look like that. It would look something like this and curved at the bottom. Oops. Like this, and it would be curved at the bottom with lateral face. If you unrolled it, it would look something like this. Okay, you get the idea, but basically you're looking at the curved part is the lateral area. So to find the surface area, we have to know which formulas for each one of those. All right, so we know the base area of a cone, which would be pi r squared, but the lateral surface area actually is L equals pi RL. Now this little L is called the slant height. R is the radius, and L is called the slant height. Okay, now how do we find slant height? To find slant height, well, we look at how the radius and the height meet each other. This is the height, this is the radius, they are perpendicular. Now what does this form? This right here with the slant height, if you go down the side, that creates an isosceles triangle. So we can find slant height by the Pythagorean theorem. Can be found by the Pythagorean theorem. It will be r squared plus h squared will equal L squared. So the radius squared plus the height squared will equal L squared because that creates a triangle. All right, so a right circular cone has a radius of 8 and a height of 15. Find its lateral surface area. Okay, the formula is L equals pi r little l. But what we're missing is what little l is. Well, again, this is a right triangle, so this is going to be 8 squared plus 15 squared is equal to L squared. So this is 64 plus 225 equals L squared. That's 289 equals L squared. Take the square root, and the square root of 289 is 17. So L is 17. So using our formula, pi times r times L that we just found, put that in your calculator, 17 times 8 is 136, and then multiply that by pi, and you get 136 pi, which is approximately 427.2566. Oh, 427. And since this is area, this would be in square units. Okay, so that's in pi terms, and that is in area terms. So that is how you find lateral area of that cone. Okay, for a regular pyramid, the lateral surface area can be found by finding the area of one face by the number of faces, by multiplying them together. So find the area of this triangle, and then multiply it by the number you'd have. In case it would be 6. All right, now, notice here the triangle, though, is slanted. This triangle right here is slanted. Okay, so S would be the length of the side. The height, actually, here, L, would be the slant height, and that would be the height of the triangle on the pyramid. And N would be the number of faces. And you also have A, which is right here, which is called the apothem. It's the distance from the center of the base to one side, because that creates a triangle. All right, so if I wanted to find the lateral surface area of the pyramid of Menkaure, we have the picture here. For the lateral surface area, it should be, we have a square base, and we have 4 isosceles triangles. So we have to find the area of the isosceles triangle, and then there is 4 of them. All right, so it's going to be L equals 1/2 S L N. All right, so S would be the slant height, or excuse me, the same length of the side, which would be 106. So that would be this distance right here. Okay, 1/2, 106. All right, L is the slant height, which would be the height of the triangle right here. Now again, we need to know what that length is, and it's slanted, so that's the slant height. We have to know if this is an isosceles a right triangle. That would make the apothem right here, the apothem, if this is a square, that's going to be halfway across, it's going to be 53. So if this is an isosceles triangle, the length right here is L squared is equal to 61 squared plus 53 squared. So L squared is going to equal 6530, if you put this in your calculator, and I'm going to leave it as the square root of 6530 for our purposes right now. So that's going to be L, and then multiply it by the height, which would be 61, or 4, I'm sorry, times the number of sides, I'm sorry, that would be 4. Okay, when you multiply all this together, you get approximately 17131.4 square meters. So that would be the 4 triangles that make that up. All right, so those are the surface area formulas and the volume formulas for a pyramid and a cone.